Welcome back. Day 2, week 2. Let's continue with the topic that we started March 28th. So we're just going to place over here that we're going to continue today on March 29th. Almost done with the month and also with the topic. And so today we're going to continue working on the rules of exponents. We saw multiplications of same basis, divisions of same basis, zero power, and the power of a power. Today, we're going to see the negative exponent and the negative power of a power. Those are the only two that we are missing, okay? So we learned that when we are multiplying same basis, we add the exponents. When we are dividing same basis, we subtract the exponents wherever the exponent is greater. If it is a zero power, then it is 1, but it has to be affected everything. If not, it is only the variable that is affected, or just one variable dependent, only the one that has the 0 on it, not the rest of them, okay? Like in this case, 3x to the 0 power, that means that the 3 is not being affected by the 0 power, so we copy the 3, and the x is affected by the 0 power, which becomes a 1, and 3 times 1, 3. Then we saw powers of a power. That's basically a distributive property of the exponent. So we did a multiplication of the powers. And today we're going to see the negative exponent. A negative exponent is actually a positive exponent that is on the opposite side of its real location in a fraction. In order for us to make it positive, then we need to change it to the opposite side of the fraction, okay? Now, in this case, in this example that I have over here, I got x to the negative 1, x to the negative 2, okay? And I'm talking about a fraction in there, but there's no fraction in here. So I'm going to make it a fraction. And I'm going to change this x that has a negative power to the opposite side of the fraction. So it means that it goes to the denominator because the power is on the numerator. So this is the same thing as saying this one, because it's already there, x, and I make the exponent positive. But remember, I cannot leave a fraction without a numerator. So I place this one over here. Now remember as well, I do not need to have coefficients ones. So this one can actually disappear. So x to the negative 2 is the same as saying 1 over x to the square. And that's how we make it positive. Now let's work another one where we have numbers, but now the negative variable, the variable with the negative exponent, is in the denominator, not the numerator. Okay, so pay attention to this. So we got 2 over 3y to the negative 4. The 2 and the 3 do not have a negative exponent, so you don't move them. You keep them wherever they are, 2 and 3, because they don't have nothing that you need to change. Their exponents are positive, okay, invisible 1. Now this y to the negative 4, in order for us to make it positive, it has to go to the numerator because it is negative in the denominator. So I copy my variable and the exponent, I make it positive. So 2 over 3y to the negative 4 is the same thing as 2y to the 4th power and that over 3. Okay, you only move that has a negative exponent. You do not change the location of those terms or items that have positive exponents. You leave them as they are wherever they are. Okay, if there's possible to simplify anything, then you simplify anything. Okay, that will be our 4th exercise. Now go to the 3rd one. We got 4w squared x to the negative 4, everything over 3y to the negative 5. Again, we're going to look on to where do we need to move. In this case, the 4th is normal. It doesn't have no negative exponent, so I copy that. The w squared in the numerator is positive, so I copy that as well because I'm doing nothing. Over the 3 is positive, so I keep it there. But you can see this x to the negative 4th power has to go to the denominator, so I can make it positive. And this y to the negative 5 has to go to the numerator. okay, in order for me to make it positive. So I'm passing the x to the 4th power, it is positive, and now the y goes to the numerator, and that would be y to the 5th power. And that's it. I finished. I made them positive. Now, can I simplify anything else and say if I need to do something else? Well, the 4 and the 3, they cannot be simplified. They're in the simplest form. And I only have one variable of each. So I can do nothing, okay? If I have a variable repeated, then yes, I can use any of the other rules that I learned. But if I only have one of each, it remains that way, okay? Okay. Let's go with the next exercise. You can see everything is like growing up. It's complexity. It's growing the complexity. Okay, so we got 8w to the 4th power, x to the -3, y to the -5, everything over 6wx to the 4th power, y to the -7. So you can see that we have variables that are being repeated, some in the numerator, some in the denominator. The first thing is to simplify whatever you can simplify. Then you make those negative exponents positive, and then you simplify again, okay? So we got numbers first, the coefficients, 8 and 6. Can I simplify the 8 and the 6?
Yes.
What number?
2.
By 2. Very good, Burgos. So I can simplify that by 2. So let's do that. 8 divided by 2. 8 divided by 2.
4.
4 over 6 divided by 2.
3.
3. Now we copy those that have the variables with the positive exponents already. So we got w to the 4th power, it remains there. Then I got x to the -cube, y to the -5. In the bottom, in the denominator, I got w and x to the 4th power. So I copy those because they don't move. They remain where they are because their exponents are positive. So they remain wherever they are. Now, I need to pass this x to the -3 down to the denominator to make it positive. This y to the -5 to the denominator also to make it positive. And this y to the -7 to the numerator to make it positive. So let's begin with the ones that we got on top on the numerator. So x to the cube comes here to the bottom to the denominator, and y to the 5th power comes to the denominator as well. And to the numerator, y to the 7th power. Okay, now as you can see, we still have variables repeated, and we are looking, what we are trying to do is to have only one variable of each type, or for the variable to eliminate it. Luis and Daniel, cameras. So what are we going to do? We are going to use the other rules that we know, okay? And we're doing it alphabetically. So I'm going to copy the 4 and the 3 because those are not going to change no more. And I'm going to go alphabetically with my variables. So we got w, x, and y in that order. So we go first with the w. We got w to the 4th power in the numerator and w to the invisible one. Remember, there's an invisible one in there in the denominator. So how or what rule should we use? What should we do? Whenever we have one in the numerator, the same variable in the numerator, and the same variable in the denominator, we do what?
Subtract.
We subtract. Where? Where should we subtract in this case? We got to the 4th power and to the 1 power. Where should we subtract it?
The 4th power.
In the numerator, right? Because we subtract wherever the exponent is greater. So we subtract in the numerator. 4 minus 1?
3.
3. Okay. Now we go with the variable x, because after w comes x on the alphabet. So we got both variables x on the same side. what should I do?
Subtract.
No. Now, pay attention to this little trick or this little tip. If we have the variables in opposite sides of the fraction, we subtract. If the variables are repeated on the same side, doesn't matter if they're in the numerator or in the denominator, if both variables are on the same side, they mean that they're multiplying. So we add the exponents. So the W's were in different sides. One was in the numerator, the other one was in the denominator. The X, they're both in the denominator. So we add the exponents wherever they are. So in this case, in the denominator. So this is going to be X 4 plus 3.
7.
7. So this is X to the 7th power. Now let's go with the variable Y, the last one. We got Y to the 7th power in the numerator and Y to the 5th power on the denominator. So we do what?
Subtract.
Where?
In the numerator.
In the numerator, because 7 is greater than 5 and they're in opposite sides. So we subtract here in the numerator where the power is greater. 7 minus 5. 2. Now I have one variable of each, no variable is repeated, and the 4 and the 3 cannot be simplified. So that is the final answer. Questions? No questions? We clear? Crystal clear? Remember, if you have questions, right now is when you need to ask them so I can re-explain. Okay, let's go to the very last. I'm moving all the way up. Then we're going to place the topic's name. Okay, so we have negative power of a power. It is when a negative exponent affects a term inside a parenthesis. In order to make the negative power of the power positive, we flip or reverse the whole parenthesis. So in order for us to flip or reverse, it means that there should be a fraction, right? Okay, so a negative power of a power is when the power of the power is negative. So the number outside the parenthesis is negative. Like in this case, we got x cubed, and that is being affected to the square. So we actually have two options on solving it, like doing the power of the power first and multiplying, just like we did in here, normal, multiplying the number outside times the numbers of the exponents on the inside. And then if it's negative, then we make it positive. Okay, that's one way. Or the one that I placed in the instructions, where we reverse first the fraction and make this exponent positive and then solve anything else. That's the one that I'm going to do. So I need a fraction, and this is only x cubed. So in order for me to make it a fraction, it is now x to the 1 power. And I'm making bigger the parentheses so I can have the whole fraction inside the parentheses. Now I need to make this positive. So I'm going to reverse or flip whatever I have on the inside of the parentheses, meaning that I'm having now, instead of the 1 in the denominator, I'm having it in the numerator. Instead of having the x on the numerator, I have it in the denominator, but nothing else changes. Okay, you can see nothing else changes. The exponents are the same, numbers are the same, nothing else changes. What changes is this -2, which is now going to be +2. Yes, Valentina. Okay, now it is a +2. So that's what we do. We just change this 2 that was negative into positive. And we reverse everything that we have on the inside. Kenneth? And then what should we do? Powers of a power. Remember, this one has a 1. So we're going to do power of a power in both parts of the fraction. So this means that you're going to have 1 times 2, 2, so 1 to the square, over x, 3 times 2, 6. So x to the 6th power. But now we need to simplify because the 1 is a number, and numbers, remember we said we need to have it in its simplified form. So I need to multiply 1 2 times. It is not 1 times 2. It is 1 multiplied twice. So 1 times 1, 1. Now, remember, whenever you have 1 to whatever exponent, it will always be 1 because 1 times itself, it will always be itself. So you got 1 to the square, 1. 1 to the 5th power, 1. 1 to the 11th power, 1. 1 to the 1,351 power, 1. Okay, it is always 1 because 1 multiplied by itself will always give you 1. So 1 over, and I cannot do anything with a variable, so I just copy my variable, x to the 6th power. So x cubed to the negative square is the same thing as saying 1 over x to the 6th power. Are we clear? Yes? Okay, let's go with the next exercise. As you can see, this exercise is similar to this one. I basically copied everything and I just open a bracket and place it to the 0 power. But before doing this, I want to do this one, okay? So I got a whole parenthesis, and the whole parenthesis has 2w to the negative 1 x squared over 3w x to the negative 3 and everything to the negative 2. So first, we're making that negative 2 positive. Okay, that will be our first step. How do I make it positive? By reversing the fraction. So I'm just going to reverse my fraction. Whatever I got on the denominator is now in the numerator, just as it is without changing anything, over whatever I had in the numerator. So in this case, over 2w to the negative 1 x squared, and everything is going to be affected now by an exponent 2, but now it's positive. Now I do the power of a power, and remember, if it doesn't have an exponent, it means that there is an exponent 1 in there, okay? We're going to do mentally the procedure. So we're going to say 3 has an invisible 1, so 3 to the what power are we going to have?
To the 2.
To the 2 power, to the second power. W to what power?
To the 2.
To the 2 as well. And x to what power?
To the 2.
No, see what exponent does the x have?
To the negative 2.
And we do power for power, so it would be x to the
Negative 6.
negative 6. Very good, because negative 3 times 2, it is negative 6. So x to the negative 6 power. Over. We're going to do the same thing with the denominator. This x looks really small. Let's make it bigger. Okay, it will be 2 to the
Power.
second power, w to the
Second power.
negative second power, because negative 1 times 2 is negative 2, and x to what power?
4.
4 power. Very good. Now, we are going to simplify in the same step this numbers, because we need to simplify form, and we're going to make positive the negatives. So I need to make first this simplify form. How much is 3 to the square? 3 to the square. It's 3 to the square.
9.
9. How much is 2 to the square? 4, right? So 4. Now, I'm going to copy the variables that have the exponents positive. So I got w squared in the numerator. The exponent is positive. This exponent is negative, so I don't copy it. This exponent is negative, so I don't copy, but this is positive. So I will copy x to the 4th power. Now that I have that, I'm going to look again for the negatives and see to what side I need to move them. So I got x to the negative 6 that needs to go to the denominator. And in the denominator, I have w to the negative square, which has to go to the numerator. Okay, so I'm going to have x to the 6th power over here and w to the 2nd power over here. As you can see, the 9 and the 4 cannot be simplified. So I'm just going to copy them, 9 over 4. And I got the same variable w on the same side. What should I do? What should I do if I have the same variables on the same side?
Add.
Add the exponents and keep the variable wherever they are, right? So I've got both variables w in the numerator. So I'm copying the variable in the numerator. And 2 plus 2.
4.
Very good. Now I got variable x repeated on the denominator. So just like we did in the numerator, I'm going to copy the variable. They're multiplying, so I'm adding 4 plus 6.
10.
10. So my final answer is 9w to the 4th power over 4x to the 10th power. 9 and 4 cannot be simplified. W and x cannot be simplified because they're different variables. That is the simplest form of that variable expression. Do we get it? Yeah, okay. Now, you see, I got the same exercise and I placed it now inside a bracket to the 0 power. My question is, should I do all of this procedure again and do the 0 power
No.
again? What should I
No.
do? Then what should I do?
Do the 1.
Place a 1. So you don't do nothing because all of this, all that's inside is affected by that 0 power. So you do nothing but place a 1 because the 0 power says that any base that is affected by an exponent 0 will always be 1. And in this case, everything that's inside should be solved, but we are not solving because it is 1. Okay. We good? We clear? No questions? Okay, then.
You can go a little bit up because I don't copy some.
There. Okay, before we go to this, before you can copy this, let's place the topic first, okay? Let's place the topic first and then I'm gonna let you copy whatever you need. What is the topic of today? What's the name of our topic? What is our name topic? What did we see here?
Exponent.
Exponents, but what are those specifically?
Introduction.
Rules. Introduction was yesterday. So today is rules of exponents because you need to learn them. These are not going to change, okay? These are the rules of exponents. And this is the topic for today. In our next class, we will continue to practice exercise that involve almost every rule, okay? We're gonna practice all of that and then we're gonna do a classwork, okay? So this is the topic. We still need to practice more and then do a classwork, but this is the class for today.